Hello. The purpose of this video is to give a fairly easy proof that the square root of 2 is irrational. And this is not the classic one or the first one I saw as a student anyway. And so let's get right to it. And let's go ahead and start right here. And I want to, there we go, makes that a little easier. Now, where I got this from was from Twitter, or X as it's now called, or whatever you wish to call it. And you can see the little brief version of this right here. And I suspect for many of you, this will be sufficient, but I'd like to go over that verbally. So let's start. We want to show the square root of 2 is not rational. Now, suppose, as a proof by contradiction, suppose the square root of 2 is rational. Then there is some minimum or smallest integer k, so that k times the square root of 2 is an integer, a positive integer. Now, why? And I want to give a little bit of background for the beginner. You might say, well, why is that? Well, if the square root of 2 is rational, then the square root of 2 can be written as p over q, where p and q are integers. Okay. And you can assume that there's no common factors. I mean, in other words, they're in least terms, and there's going to be a smallest one. Like for example, q times the square root of 2 is p is integer. So we're going to assume that k is the smallest integer, such that k times the square root of 2 is itself an integer. Okay, so we know that. So now here's what you do. Now, and I should probably switch back to black here. Now that we know that, what you can say right here is now we can write 2 right here, 2k minus the square root of 2k is an integer, and it's a positive integer. And the reason why you know it's a positive integer is 2 is bigger than the square root of 2. Now, if you're such a purist that you want to prove that, we'll prove that at the very end. But if you take for a fact that the square root of 2 is less than 2, you can make this move. Now that you have this as a positive integer, right? Then what you can do is you can factor out the square root of 2. So this is the square root of 2 times the square root of 2. K is the square root of 2k. And I shouldn't say is, darn it, I meant minus. So all I did was use the definition of what square root means. So these two are equal. Now, using a little bit of algebra, we can factor out the square root of 2, and we have the square root of 2k minus k. These are equal, right? But we know that the square root of 2 times k is an integer. This is an integer. This is an integer by definition. So we know that the square root of 2k minus k is a positive integer. Because that's, of course, square root of 2 is greater than 1. And again, we can prove it might be a hidden assumption for some of you, but we can go ahead and prove that. So we know that the square root of 2 times this integer, this is now an integer, is equal to an integer. So now we have the square root of 2 times, I'm going to use a different color here. Let's use this color here again. It's pretty. Times k times the square root of 2 minus 1 is an integer. But this is an integer because we just said that right here. The square root of 2 times k is an integer because that equals that. And k times the square root of 2 minus 1 is less than k. Okay? But what did we assume was true about k? And this is the thing. We see right here some minimum, smallest integer k. Okay, such that the square root of 2 times k is an integer. But now we've now displayed an integer less than k that when multiplied by the square root of 2 gives an integer. So k is not the least integer. And that's a contradiction. So the conclusion is that no least integer, integer can exist. And there has to. Now, the last just a little bit, now the hidden assumption. And the hidden assumption is that 1, square root of 2 is between 1 and 2. Now, how do we know this? Well, the very first thing we want to do is, we know this because if we apply the squaring function, which is 1 of, there's a 2 and here's a 4, is true. And it's true because the square root of this is true because the function f of x equals x squared is increasing on the the non-negative reals. Now, the question is, if we want to say it's increasing, how do we show that? And I'm not going to use calculus. So to show this, to see this, let's say x is greater than t. Then, and let's say it's greater than 0. Now let's square this. So now we're given this. We're given that x is greater than t is greater than 0. Now, if we look at x squared minus t squared, we want to show that this is positive. And to do that, that's actually kind of easy. We just use a little bit of algebra. We take x squared minus t squared is x minus t, x plus t. But this factor is positive because x is greater than t. And this is positive because x is greater than 0 and t is greater than 0. So this is greater than 0, which implies that x squared is greater than t squared. So the function, the squaring function, is increasing. So we can actually assume this. So that's what I have here. Let's get out of this. And thanks for watching.